Okay. Ready to pray?
Yes.
In the name of the Father, and of the Son, and of the Holy
And
Ghost.
of the
Holy Ghost, amen.
Come, Holy Ghost, fill the
Fill
hearts
Fill
of
the hearts of
thy
thy faithful and
kindle in them the fire of
fire
thy
of
love.
love.
Send forth thy Spirit, and they shall be created.
And also to the face of the earth.
Let us pray, O God, who didst instruct the
The
hearts
hearts
of
of
thy
thy
faithful
faithful,
by the light of the Holy Ghost.
grant us
Grant
light,
us in that same Spirit
to
to be truly wise and ever to
and to
rejoice.
rejoice in consolations through Christ our Lord. Amen.
Our Lady, seat of wisdom,
Pray for us.
Saint Thomas Aquinas,
Pray for us.
Saint Augustine,
Pray for
in
us.
the name of the Father, and of the Son,
And of the Holy Ghost. Amen.
Okay, so Michael, you did 410 or Patrick, you did 410, I believe.
Yes.
Yes.
Okay, Patrick, why don't you do 411?
Oh, okay, yes. In a given circle, to inscribe an equilateral and equiangular pentagon.
Good. Okay, you should be able to click in.
Yes.
That's funny. It's so sensitive, the microphone. Just clicking on the mouse key sounds like you're banging.
Whoa.
Just clicking on the mouse button.
So the given is the circle HKLFZ.
Okay. And what are you doing?
And I am inscribing an equilateral and equiangular pentagon in the circle.
In what?
Oh, in the circle HKLFZ.
Like that?
Yes.
Okay.
For let the isosceles triangle be set out oh yeah, that's right. You're covering L. Let the isosceles triangle TWA be set out having the angles WTA WAT, double, both of them double of the remaining angle at W, invoking prop 4.10. And in the circle HKLFZ, actually, no. Yeah. What? So in that circle, let the triangle LHF be fitted in the circle. I mean, inscribed in the circle, being equal angular with the isosceles triangle TWA, so that the angles uh, WTA is equal to the angle. I mean, so that the angle WTA, WAT are.
You can just use the letters when there's no,
Yeah.
and
Oh,
use your
yes.
mouse, right?
Yes. So
Use your
that.
mouse so the angle at T is equal to the angle at L and so on, okay?
Yes. The angle at T is equal to the angle at L. The angle A is equal to the angle at F. And the angle W is equal to the angle at H. So that the angle at both the angles at L and F are also double of the angle at H. And that's invoking prop 4.2. And let the let the angle LFH and HLF be bisected by the straight lines FK and LZ.
Again, Patrick, just try to always keep it simplest.
Because yeah. So
Move
yeah.
your mouse
Let's
and just say
yeah.
that.
Let the angle at L and the angle at F be bisected by the straight lines LZ and FK.
Good.
And let KH, HZ, ZF, and KL be joined.
Yeah, moving the mouse helps a lot.
Yes.
Otherwise, it's just a sea of letters.
Yes.
Just press enter. You don't have to
Yes.
click again. Yeah, okay. Press enter now.
Doesn't do anything.
Oh, okay.
Just go over here like this.
Oh, okay.
See, you hold the mouse and like move it.
Sorry. Oh, I see. Okay, then because the angle HLF, HFL, both angles are to get not just by themselves are double of the angle at H or the angle LHF, and because the two big angles at L and F have been bisected, therefore the five angles L H L H L Z.
You can just, why don't you just say them?
Yeah.
The five
Okay.
angles here and so on.
Okay. Yes. Five angles here, 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 and here, and wait, yeah, so uh, so here, here, here and here are all equal to each other.
Okay.
And equal angles stand on equal circumferences, invoking Prop 3.26. Therefore, the five circumferences KH, HZ, ZF, FL, LK are equal to each other. But equal circumferences are subtended by equal sides. Therefore, the five sides KH, HZ, ZF, FL, LK are equal to each other. Therefore, this five figure is equilateral. Sorry, the pentagon is equilateral. Next, I say that it is equiangular. For since the circumference ZF is equal to the circumference HK, let wait, sorry, since the circumference ZF is equal to the circumference HK, let the whole circumference KLF be added to each. Therefore, the whole circumference HKLF is equal to the whole circumference ZFLK, and the angles on equal circumferences are also equal. Therefore, the angle KHZ is equal to the angle HZF. Similarly, we can prove that the angles ZFL, FLK, and LKH are also equal to KHZ and HGF. Therefore, the pentagon is equiangular, but it was also proved equilateral. Therefore, in a given circle, a pentagon that is equiangular and equilateral has been inscribed.
Good. Michael?
Yes, pretty good.
Yeah. Yeah, you kind of wondered maybe that long Prop 410 where he's creating that special isosceles triangle. You kind of wonder what it's for, right?
Wait,
Yes.
yeah, it's probably for this.
Yes. And
Yes.
just like in book 2, I was wondering what in the world would Prop 11 be used for? To cut this straight line, so that the rectangle, that one, and happens to be it's used of it's a very the very important part of Prop 10.
Yes. Yep. And it'll probably get used again.
Yeah.
Yes.
So it's kind of neat. Makes you try to figure out how Euclid did all this. Did he?
Mhm.
Remember, a lot of this was put together before Euclid. I mean, he was pulling pieces. A lot of it's new, I think, that he invented, or that he discovered. But
Yes.
it makes you wonder what order and how did he come up with things? Did he see a need and then go put a prop back in, or
Yeah.
yeah, very nice. I think this is a neat prop.
It is, yeah. I like the bisecting part. How they're all equal, those angles and everything.
Mhm.
Yes. And how he goes from, see other steps?
Yes,
Yes.
that's yeah.
From equal angle to what?
To equal circumference to equal side.
And then to equal side, yes.
Yes.
Yeah. Angle to circumference to side.
It's really neat, yeah.
Yeah.
Dad,
Right.
I don't
Yes.
know if just really quickly, it's kind of an optical illusion. It looks like the circle goes in at these points right here. It's really weird.
Yes, I would always
Especially right
notice that
here.
too. Like
Looks
when,
like it gets pushed down, or it gets crimped in a little.
Yes,
Yes.
yeah.
or if
That.
squares. Oh,
Oh, I see what you're saying. Yeah, it looks like it gets flattened out at the points where the.
Yeah.
Oh wow, yeah, that is an optical illusion.
yeah,
Neat.
yeah. I saw that for a while. I was thinking how that happened, and I can tell. I saw that if a square is or a straight line figure is circumscribed around a circle, the lines where it touches it appear to be bent inward.
Oh really? Oh,
Yeah.
okay. So if we had the reverse, you're saying.
Yes.
Oh, you're seeing if that was around. Oh.
Yeah. I might be able to show you. Yeah.
Really? Oh, yeah. That's true. Yeah,
Is it? Am I doing that right?
Yes.
actually, I can see why. Yeah.
It looks like the straight lines get kind of bent in towards the circle.
Yeah, right here, right here, right here, and right here. Or the
Yeah.
point of contact.
It just
It's weird.
you have to think about it, and then you have to. Yeah.
Yes. Yeah, that is neat. Huh, what's going on with our eyes there and our brains and
Yeah.
neat.
Neat.
Makes you also wonder how the computer draws a circle.
Yeah. Well, it doesn't. This might not necessarily. Wait. Well, is it always a circle, or can you?
What's that?
And with this tool, is it always going to be a circle, or can you make it oval
No.
with the
it's
same?
Sure, whatever you want.
Yeah. See, I guess you don't really know if you are
Yeah.
doing a circle when it is.
That's true. But if it had a mode where you can for sure draw a circle, I mean, you can see that it could do it if it just locked you in.
Yeah.
I mean, they could have added an option to say limit to a circle or something.
Yeah.
Mm-hmm.
But I think if you draw it big enough and then zoom in, oop, look what's happening. See that?
Oh wow,
Yeah.
that's really neat.
Mm-hmm.
This one.
You can see I didn't do a very good circle there because it's not.
It's not all the same.
Yeah.
Yeah.
Oh, that's weird.
Okay, enough fun stuff. Michael, how about prop 12 then?
Yes. Uh, to inscribe a circle. No, wait, no. To circumscribe an equilateral and equal angular pentagon around a circle.
Okay.
I want to move it.
Yeah.
Just up, not to the left too much.
Oh, yes.
Yeah, that's good.
Yeah. So we're given the circle named ASD, and B. And we have to draw a circumscribe a equilateral and equiangular pentagon around it.
Around what?
Around the circle ASD.
Okay.
Yeah. For let A, S, D, N, and B be conceived be the angular points of the inscribed equilateral and equiangular pentagon, and at those points, let these lines be drawn. I'll think about the letters.
Just make the lines longer than you have to, if that way you don't have to go back and mess around. Okay. Doesn't hurt.
Yeah.
Doesn't hurt to have some excess.
Yeah.
No bother. No. That's not me. Don't
Yeah.
bother. Just move on.
Yes, and
Oop. Yeah, don't do that. Just backspace.
Yeah.
Space. Okay, now type.
Oh yes. And let F and at A, B, N, and D, and S, let F, H, H, P, P, L, L, G, G, S be drawn touching the circle A, S, D, and B, and let the center of the circle ASD be taken, and let it be named T. Yes. And let TS, TG, TD, TL, and TN be joined.
Now watch how he does that, Mike Patrick, with the mouse, and so he can release and so on.
Yes, yeah.
Oh, I'm gonna rename T. Then because G then because FG touches the circle ASD at S and I mean sorry and SD is ST sorry it's the center and at the point of contact touches the and is joined from the center to the point of contact. The angles at S are right. Let's see. Similarly, we can prove that the angles at D and N are right. Then because yes. Then because this and because the angles at D are right, the square on TG is equal to the squares on GT and DT, invoking Prop 147. And the square on TG is also equal to the squares on GS and ST, invoking Prop 47. Again, therefore the squares on GS, ST are equal to the squares on TD, DG. But the square on ST is equal to the square on DT because those lines are equal. Therefore, the square on SG is equal to the squares on GD. The square on GD. Therefore, those lines are equal.
Good. Why don't you mark it as such?
Yes. And you could see that these are equal to then because SG then because SG is equal to GD and GT is common, the two sides SG GT are equal to the two sides GD DT and the two sides SG GT are equal to the two sides DG GT and the base ST is equal to the base TD.
Patrick, no.
Yes.
Therefore, the angle SGT is equal to the angle TGD. And the angle STG is equal to the angle GTG. GTD. Similarly, we can prove that the angle DTL is equal to the angle LTN, and the angle DLN to the angle the angle DLT to the angle TLN. But the circumference SD is equal to the circumference DN, and the angle STG stands on the circumference SD, and the angle DT and stand on the circumference DN. Therefore, the angle therefore,
Go ahead.
yes, therefore, the angle STD is equal to the angle DTN. Invoking prop three I forgot 327.
Michael, better to do this sort of thing.
Yeah.
So it's clear you got two, instead of, you guys sometimes will just do this. It's like, it doesn't
Yeah.
make any sense. Okay,
Yeah.
try it again.
Yeah.
Well, what I'm really trying to show you is you make your angle thing go in and out like that. Do you understand?
Yes.
So it's clear where one ends and another begins.
Yes.
Okay. Okay, good.
But the angle STD is bisected by the angle TG and by that line TG. And the angle DTN by the line TL. And therefore the angle STG is equal to the angle LTN.
And you could use a different color if you
Yeah.
want, or whatever. Got a lot of colors to choose from, so use them up.
Yeah.
Yeah.
No, wait, sorry. I have to prove first that the angle GTD is equal to the angle DTL.
Okay. How do you prove that?
Because side angle side, this is a right angle. These two are right angles, and then D. Wait, what is it? Oh, wait. No, I forgot.
Can you help him? Give him a hint, Patrick?
Yes. Well,
So what are you trying to do first, Michael? I'd like to show.
I'd like to show that that the lines of the pentagon are equal and the angles are equal too.
Okay, good. That's the really big picture, right?
Yeah.
Which one of those big steps are you working on now?
The lines are equal.
Yeah, say to show that it's equilateral.
To show that it's equilateral.
Right. So the big picture here is, I mean, the big sub step we're working on is working on showing it equilateral.
Yes.
But you were just working. You were trying to. You corrected yourself when we're trying to show something. You said if I could show these two things equal, what two things are you trying to do? What mini step right now?
Oh, well, that's the angle GTD is equal to the angle DTN. I mean DTL.
Right. So that
Yeah.
this angle I want to show is equal to this angle,
Yeah.
and you don't know how to do that.
Yes.
Okay, Patrick, can you ask him?
Yes. Patrick, can you help me?
Yes.
Can you give me a hint?
Can you give me a hint?
Well, it's basically the same. The reason behind it is the same reason you said that STG is equal to LDTN.
The same reason that STG is equal to what?
LTN.
Okay, those two angles equal.
Well, Michael, what did you prove that those two blue angles are equal, right?
Yeah.
And you the I think I don't know if you did the mini. I mean well, yeah. What can you say about what do the straight lines TG TL do to those two bit blue angles?
They bisect them.
Right. And if the two blue angles are equal, what does that say about either of those four angles, mini angles that are bisected?
Oh, that's very equal.
Right. So all the angles at T are equal then.
Yeah, that's right. Yeah. Yeah, that's right. It does that. Just
Right. It's not like a property.
Mm-hmm.
Okay, so mark it as such, Michael.
Yeah.
You say it in your own words.
Yes. Well, because T S T S T D is and DTN are bisected by the lines DG, TL. And they're equal. Therefore, all the angles
What are equal?
the two angles STD and DTN.
Right.
The blue lines show us they're equal,
Yeah.
right?
Yeah.
And yet they're bisected.
Yes.
That means what?
That means that
About their halves.
Oh yes, that means that the halves are equal to. So actually,
You don't have to do whatever. Do it. Yeah.
I mean. Uh,
Now what?
uh, then because the angle. Okay, yeah, that's right. Then because the angle GTD is equal to the angle is equal to the angle DTL and
Hey,
this,
better if you guys, instead of moving them like this sort of thing, it's just not very helpful. Rather, just calmly, since the angle GTD is equal to the angle DTL, something like that, okay, is a lot more helpful than flicking the mouse along tracing the
Yeah.
triangle or something,
yeah.
okay?
Yes. Then because the angle GTD is equal to the angle DTL and the angle DGD, I mean TGD is equal to the angle TLD, and then the triangle TGD, then the triangles TGD, TLD are two triangles having two angles equal to two angles and one side equal to one side, namely TD, which is common to them. Therefore, the angle, therefore the remaining sides will be equal to the remaining sides. So GD is equal to DL. And the angle TGD equal to the angle TLD. Invoking prop 126. But the therefore the line, therefore GL, the line GL is double the line GD. And similarly, we can prove that FG is double FS PL of PN HP of HB HF of HA but no, actually no, sorry, we only prove that LAC. Similarly, we can prove that only FG is double FS and PL of PN. Therefore, and but SG is equal to GD. And D. Therefore, the line FG is equal to is Therefore, the line FG is equal to the line GL, and the line PL equal to the line LG. And similarly, we can prove that FH is equal to, that all the 5 lines are equal. Therefore, it is equilateral, and therefore the pentagon is equilateral. Next I say it's equiangular. Because he was proved, we proved that SGD was bisected by GT and DLN by LT. But the angle TGD was proved equal to the angle TLD. Therefore, the angles SGD and DLN are equal. And similarly, we can prove that the other angles at F, H, and P are equal also. And, equal all the lines at the angles at F, H, P, and L and G are equal. Therefore, it's equiangular, but it was also proved equilateral. Therefore, around a circle, equilateral and equiangular pentagon has been circumscribed around A, S, D, and B.
Okay, Patrick.
Yeah, it was pretty good.
Okay, pretty good, but not perfect.
Well, well, there were some
What parts are you troubled about?
Well, for one thing,
Asking questions. Okay,
yes.
yeah.
How do you know GT is equal to DL again?
GT? Oh, because remember I proved by Prop 126 that remember this angle is equal to this angle equal. Sorry. This angle was equal to this angle. These two right angles are equal.
Okay, yeah. Well, yeah. See, you in the proof you said because this angle is equal to that, and that angle is equal to that.
Right.
And that's common, therefore that's equal to that. And then you said, therefore also that's equal to that too.
Oh,
So
okay.
yeah, I just
Good.
Go. What were you gonna say? Something?
Yeah, good, Patrick.
Oh,
Michael, do you understand?
Yeah.
You use the givens. You use the givens to prove the givens, or something like that, or you use the proof to prove the proof, or something. I'm not sure.
yeah.
Okay, good. So, but now you said it right.
Yes.
Given the fact that you've got this set of angles equal and this set of angles equal, and any side basically angle. Actually, angle. It's only angle side. No, there's angle side angle too, right?
Yeah. Right. Yeah.
Either one works.
Yeah.
Then you can prove that this green is equal to this green. Good.
Yes.
Okay. And what else, Patrick?
Do you think you could just say again why FG is equal to GL?
Good. Those are my questions exactly.
Oh.
In other words, guys, it's easy. It's easy for us listening, and you should do this too, Michael. When you're the listener, it's easy to see. Usually, easier to see where the person really doesn't get it. Even though they may not realize they don't get it. It's funny how we are. We don't sometimes we don't get it, and we know we don't get it, and we're trying to slide by and just kind of and that's really bad. Rather just
Yeah.
say I don't really get it, but this is the parts I get, or whatever.
Yeah. Oh yes. Okay. So well, we proved that by Prop 126 that GL is double of GD, and we said I proved similarly that FG is double SG. But we proved even further back that SG is equal to GD, as you can see by those black lines. So that means that they're both. That means that shows that both the big lines are double of either of those smaller lines. Therefore the big lines are equal.
Yes, yeah.
Good. You didn't do that last time in the prop.
Oh, okay.
You said, therefore FG is double of FS.
Oh yeah. Mhm.
And that doesn't really help us to prove that we
Yeah.
want FG double of SG and so on. Yeah.
Mhm.
Good. Okay. Now this is a longer prop with a lot of steps in there.
Yeah.
Just like the one you did last time, Patrick. And so I hope you guys are using the recommended method, which is to read the prop. Just kind of read the prop. Don't worry about every little step, and just try to pick the big steps out and see what are the big steps, right?
Yes,
Yes.
yeah, that's what I do. Yeah, it really helps.
Yeah. So in this one, looks like about 3/4 of the prop is to prove finally. You want to prove two big things at the top, right? What are
Yeah.
the two big things?
Well, that's equilateral and equiangular.
So here they are. And at the bottom of the 3/4, he proves that it's equiangular, right?
Yes, right.
Yeah.
And then maybe a fourth more or whatever to prove equiangular. Did I say that right? Equilateral
E-
and then
that is,
equiangular.
yes, right, yeah.
And then in there are many steps. And that's the key thing is, first of all, make sure you see the big picture. Okay, look, it's basically here and here. I got it. Okay, big steps. In order to get to big step number one, I got to do this and this and this or something, right?
Right, yeah.
And just if anything else, just memorize these.
Yes.
Mhm.
I see, and then it'll come back to you probably how to do the little nitty gritty grunt steps in here
Yes,
Mhm.
yeah.
and so on.
Yeah.
Yeah.
So make sure you do that. So I would say the first reading, try to pull out, this and this, and if you can, these smaller arrows here, here, and here, and then maybe there was one in here or something too.
Yes.
So all you have in the first reading is 5 or 6 things.
Right, yeah.
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 Make sure you get. That was one of the most useful tips. I mean, it seems like common sense, but you might find yourself on the first reading trying to follow on a longer prop, and it's really going to mess you up trying to follow every little. How does he go? You're gonna probably not see the forest of the trees. Go the other way around and see the big steps first, and then you can probably figure it out yourself. The little gritty steps.
Yes, yeah.
Yeah.
Good. All right. Any other? It's a neat prop. Any other
Yes.
Yeah.
points on that?
I don't think so.
No.
Okay. Okay. Patrick, then you can do 13 for us.
Yes. To inscribe a circle into a equiangular and equilateral pentagon.
Michael, is that right?
Yes.
Good. Use the pentagon tool there, Patrick.
Oh, yeah. Whatever.
You can make it a little bigger probably if you want.
Yes.
Yeah. Good.
Oh.
Just right.
Yes.
These tools aren't cheating or something. They're just, they just save us time.
Yes.
Yeah.
Okay.
We know we can draw a pentagon by hand if we wanted, and it just
Yeah.
won't take longer and won't look as nice.
Yeah.
But on the other hand, there is something to be said. If you look, the pentagon you draw, if you actually do try to draw one by hand, it is actually a little bit of a trick. You find these angles, it's not so easy to get them right.
Yes.
Yeah.
Okay, go ahead.
Yeah. At the same time, being equilateral. Yeah.
Yeah.
Yes.
Yeah.
Yeah.
Well, maybe I should have had you do it.
Yeah.
Yes.
Michael, I hope you're not being silly. Yeah, I hope you're not. Are you?
No.
Okay.
Oh yeah, I didn't even. So the given is the pentagon equal angular and equilateral pentagon PQMNO. And yeah.
Okay.
Oh.
Equilateral and all right. And what about it?
I am trying to inscribe a circle into it.
Shoot. Oh well. Yeah, I messed up there.
Yeah, that's okay.
Inscribe a circle in there, right?
Yes. Yeah.
See if I can mess up again here. Okay.
Yes.
All right. Go ahead.
For let the angle QMN. Oh, sorry. Let the angle at M and N be bisected. And let them meet at K. Invoking prop 1.9. Oh, I should do that. That's right.
You could just hit space or something, or if you want to move it over or something. No, not
Yes.
anymore. Too late now.
Yeah. Yeah, see, I already had clicked out of it, so before.
Okay.
So,
Use
yeah.
a razor.
Yeah, because it'd probably be in the way, I would think. So,
Sure.
Maybe just do it after.
Yeah, I guess. And let PK, KO, and QK be joined. Oh. See if I can remember. Oh. Can't do that later. Yeah. So then, because QM is equal to MN, or the given as they're equal at lateral, and MK is, or sorry, yeah, MK is common. Therefore, the two sides QM, MK are equal to the two sides MN, MK, and the angle QMK is equal to the angle KMN. For it was bisected. Therefore, the therefore the base QK is equal to the base KN.
It's nicer if you mark them as you go.
Yes. And also, the angle MNK is equal to the angle MQK, invoking prop. That is prop 1.4.
And why don't you mark the other ones that you bisected too?
Oh yes. Then because the angle MNO, MNO is is double of the angle MNK.
Yeah, why don't you don't flick it around, okay?
Yeah.
Because MNO, this whole angle, is
Yeah.
double of this angle, okay? Something like that.
Yes. Because the whole angle MNO is double of the angle MNK. Well, and the whole angle MNO is equal to the whole angle MQP, while the angle MNK is equal to the angle MQK. Therefore, the whole angle PQM is also double of the angle MQK, so that the angle MQK is also equal to the angle KQP. Similarly, we can prove that the whole angle QPO PON are also bisected by the straight lines PK and KO. Then let just
Do it.
whatever.
You can't do it so fast.
See, then it does. I don't know. Sometimes it's just flaky. I don't think I'm doubling any. Yeah. For and let AK, KB, KC, KD, and KE. Wait, did I? Yeah, KE be drawn perpendicular to the straight lines QM, MN, NO, OP, and PQ. then because the angle QMK what is it? I mean, whatever. You can see my mouse, right?
Yeah.
Okay, good. Then because the angle QMK is equal to the angle KMD.
You can just press escape on your keyboard.
Okay. While the angle. Wait. Yeah. Sorry, I should have said. Well, I mean, obviously, because I drew those lines perpendicular, therefore, the angles are equal. I mean, are right angles, therefore they're equal. But so because this angle is equal to this angle, while the angle MDK is equal to the angle MEK. Therefore the triangles EMK and KMD are two triangles having two angles equal to two angles and one side equal to one side, namely MK, which is common. Therefore, the remaining sides will be equal to the remaining sides. Therefore, KD will be equal to EK. Invoking Prop 126. Similarly, we can prove that the straight lines QK, PK, wait, sorry, no. Similarly, we can prove that the straight lines AK,
Why don't you mark them as you go?
yes, AK, BK, and KC are also equal to the straight lines EK and KD. Therefore, the five straight lines, those five aforesaid straight lines are equal. Therefore, the circle described with center K and a distance any of the straight lines AK, KB, KC, KD, or KE will pass through the remaining points. And the circle will cut the straight lines QP, PO, ON, NM, and MQ for the angles ED, C, B, and A are right. And the circle will not cut those straight lines QM, MN, NO, OP, PQ. For if it does, then the straight lines drawn at right angles to the diameter of the circle, at the extremity of the diameter of the circle, will pass through, will fall within the circle with the opposite. Therefore, the circle will touch the straight lines QP, PO, ON, and MQ, and let it be inscribed.
Ooh, nice.
Yeah.
Therefore, this circle, AEDCB has been inscribed in the pentagon in the given equiangular and equilateral pentagon. Therefore, a circle has been inscribed in a equiangular and equilateral pentagon.
Very good. Michael?
Yes. Very good.
Yes.
Thank you.
Excellent.
Thank you.
Good. We're going to quit there, and next time, since it's just tomorrow, you guys will have an easy day, okay?
Oh,
That's just to finish book 4.
Okay, yes,
Okay.
And that's just basically doing two more props, 2 new ones, one of which you've already done. You've already prepared, so excellent work.
Thank you.
Neat props, huh?
Yeah, oh yeah.
They're getting longer and a little harder, and they're bracing you for things to come.
Yes.
And
Yeah.
beautiful props to come. I mean, these are so beautiful in themselves. Don't get me wrong.
Yeah.
I remember when I did it the first. I think I kept hearing things like that and thought, okay, wow, okay, yeah, get past this stuff, and then you kind of later. I mean, they are beautiful props, but you're missing out on the beauty right here too.
Yes. Yeah.
And this is really neat stuff to be able to do what you're doing.
Yes.
You
It
could
is.
build a building, the famous Pentagon. You know what our Pentagon
Oh
is,
yes. Yeah. The army building. Yes.
right? Not just army, but our whole what?
Oh. Um.
Michael?
Is it like a bank or something?
A bank. Come on. Patrick's closer, much closer with the army, right? It's
Yeah.
it's our defense building,
Yes. Yeah.
but it's not just uh it's not just the army.
Yes.
Mm.
Yeah. Yeah. Because that's simple.
Right there it is.
Yes.
Yeah.
It's the most secure building in America. It's our entire military, not just army, but what else?
Navy. Air Force. Marines.
You
And
can see my browser, right?
Yeah.
yes. Yeah.
Yeah. Air Force, Marines,
Guard.
Navy, yes, Coast Guard, National Guard, all that business is all in here. It's one of the biggest buildings in the world. And if you
Oh wow.
look at it, look at the cars here, right?
Wow. Yeah.
Now look at the building. It's layers of layers within layers of layers and 5 sides. I mean, it's humongous. Just look at all the
Wow.
just if you just saw one of these buildings like this, it'd be a big building. But this
Yes.
is
Yeah.
this
Yeah.
is look at the just to walk from here to here would take you a couple minutes.
Right.
Yeah.
Yeah.
To walk around the entire thing, I bet it would take 10 to 15 minutes to walk, or 10 minutes or something to walk around the whole thing. And that's the very building that the plane crashed in with, in
Yes. Yeah.
911. I don't know which side or whatever it hit here, but okay. Anyway, good job.
Yes. Thank
Yeah.
you.
So next time, finish book 4.
Yes.
Yeah.
Yeah.
Yeah, good.
Okay. Thank you.
Yes.